So in order to address our overarching research question, it's really important to have a very careful program of study. And for us, this means we need several steps. And the first step, which is actually what we're doing right now out in the forest, is to gather pre-treatment data. We want to know how that forest is operating, what the health of that forest is before we do anything at all to the treatments. The next step is to actually do the manipulation. In this case, it will be this winter. We'll be doing the icing. And it will be very important to take very careful measurements of actually how much ice we put on those forest trees. The next step is to evaluate the response of that system to the manipulation that we impose. We're going to go out and create our own ice storms. And using firefighting pumps and hoses, we're able to take water, in this case actually from the Hubbard Brook. We shoot it up through holes in the canopy to the tops of the trees. The water comes down, is set to come down as a fine mist. And again, if we do this in the middle of January or February or New Hampshire, it will freeze on impact. So our program of study for our new ice storm experiments includes setting up 10 large experimental plots. These are 20 meters by 30 meters in dimension, and we have 5 different treatments. We have the control, where of course we won't do anything. We have a low disturbance, which is a 1/4 inch of ice. We have a middle disturbance, which is 1/2 inch of ice, and we have an extreme disturbance, which is 0.75 inches of ice. And then we have a 5th one where we will repeat the 0.5 inches of ice over 2 separate years. So scientists often focus on different variables that we can manipulate, very carefully manipulate. In our case, what we're manipulating is the amount of ice we're putting on those trees and the frequency of those ice storms. It is also important as scientists to have very clearly defined metrics of response. So what do we care about? How do we measure the response of forests to this perturbation? In the ice storm, we're really focusing on carbon and nitrogen. And in carbon, think of carbon being in the wood, in the foliage. So when we bring down branches, we bring down twigs, we want to measure very carefully how much of that goes from the canopy down onto the ground. In addition, we're putting bands around the trees, so in consecutive years we can see how much they grow and whether they grow more or less after the ice storm. And we're also measuring how much carbon they're respiring. So we put collars on the trees. We can actually measure bollwood respiration. We can measure soil respiration. So again, the amount of carbon going out of the trees and the amount of carbon coming into the trees. Similarly, for nitrogen, we can measure amount of nitrogen in the wood, in the leaves, how much comes down from the wood and the leaves that falls during the ice storm, and what happens to that nitrogen as it's processed in the soil and is eventually exported into surface waters. So primarily in our experiment, we're following what happens to carbon and nitrogen as it's moving into, through, and out of the system, and how the ice storm is affecting that movement.
Visit the Natural Enquirer website for more information. There you'll find more about how to plan and test your question.